Student, let us start with the model 1. The first model, in this one we will cover the first solar resources. We almost know the sun is very important source of energy, and directly or indirectly as a wave or a wind it comes in the form. And if you see particularly the plants take the energy in the form of photosynthesis. They take sunlight, carbon dioxide and water, and they convert it into carbohydrates. That is a source of energy for the plants. And if in the sun, if you see the sun, a sun emits lot of energy, or it gives endless energy. This process, it is known as a nuclear fission, where a lot of amount of energy is released. In this one, what happened, the particularly hydrogen atoms combines with the atom of the helium, and in when this process combination process or fusion process place large amount of energy it is produced. In the helium also, in the helium atom also, when it combines with the hydrogen atom or other helium atom, that also releases more energy. And when this energy is emitted, it is emitted in the form of electromagnetic radiation. Electromagnetic radiations are useful in many forms, like microwave, which is used for cooking, radio wave, which is used for telecommunication, and telecommunication. So, the solar cells are designed to capture this energy. Now, power and energy, as we know, the power is nothing but P is equal to VI. So, the energy, whatever the energy of the sun, it is a measure in the form of energy is equal to power into time. Power into time. And this figure, particularly if you see this figure, this shows a small. It is a kite craft designed by a Japanese in the space to capture or to absorb the solar energy. And this one, it is we know all that we know that energy, it is released from the sun, and it is used to produce electricity. And particularly this, if we see this image, in this image it is shown that there are many lights in the sun. If you find many lights of a different colors, it is having different wavelength, it is having different frequency, and depending upon length and frequency it is used. Now let us move to the quantifying solar energy. Quantifying solar energy, the amount of radiation is emitted from the sun. That is very important. How much it is reaches. It depends upon the Earth orbit, rotation of its own axis. For example, Earth orbit. If you see at the equator point, the energy is a more. The radiation of the sun emitted is a more. At that surface, radiation received is more. But if you see at the North Pole and the South Pole, that South Pole, the radiation of the sun is very less. So it depends upon the axis and the rotation. Day and night process also. If Earth is facing towards the sun, it is called day. Lot of radiation is emitted, lot of radiation is absorbed by the surface of the Earth. Doing the rotation, if the, half of the part is does not receive the sun rays, that is we call as a night, where there is no radiation. So solar array, if you see this one, the particularly they have shown the graph. This is the average, we call as average insolation for the Boston means it is a place where the radiation of the sun, it is a measured from January to the December. The amount of the sun, particularly in May, June, July time, the radiation amount of radiation will be more. So the designers, what happened, the designer need to see that how much a radiation a site will be having. For example, if they select a site and want to install solar PV cells, that time throughout the year they will take the data and they will check what type of, how much the radiation they are going to get, how much the sunlight is there. If it is good, then only they will install the solar panel. So the amount, we call it, we measure this amount of energy, we measure in kilowatt hour per meter square per day, or peak sun hour. It is called as a peak sun hour, that is PSH. And the important thing is that in this one PV array, they will tilt or they will rotate the arrays in such a way that it should be always facing towards the sun. Now in this one, small data they have been obtained, or any observation they have done in this one. It is observation done at London. London, it is done in observation is done in London, and it is for a day. For it is full day. You can see it is for a full day. If you see from morning, the radiation which is absorbed from morning till evening, the graph goes on changing. But between 10 a.m. to 2 a.m., the amount of energy absorbed, the amount of energy given by sun is more.